The feeling before the question. There is a particular kind of quiet that belongs to this hour. Your body is heavy in a specific way. It is not heavy during the day, not tired exactly, not ready to go either, but somewhere in the middle of those two things. Suspended, the way a breath is suspended when you have just exhaled and have not yet decided to inhale again. The ceiling is there. You might be looking at it. The room has its particular texture of dark and near dark, and the sounds are the sounds that only this hour carries. The refrigerator doing its low work, the building settling into its own weight. Someone somewhere who is also still awake and does not know that you are too. This is the kind of hour when things that normally hide behind the noise of the day come slightly closer to the surface. Here is something that has always been happening, something that the universe, for reasons that took centuries to understand and still feels slightly unacceptable, has never allowed to go beyond a certain point. We are going to spend some time with that. No rush. The Sleepy Science channel is still here, still running, and that is because of people who have chosen to keep it going, which still surprises, which still lands quietly as something that matters. If you have ever thought about supporting it, or sharing it, or simply staying, it still goes a long way, more than is easy to say out loud. The room is still there, still dark. Go ahead. The first thing to set aside is the idea that speed is something you have ever fully understood from the outside. You have felt speed before. You have felt it through glass, through wind, through the particular compression of air against a face going faster than a face usually goes. And in those moments, the body does something automatic, which is to locate itself, to take a reading of how fast and relative to what. The reading happens without asking. Something in the inner ear, something in the eyes, something in the pressure against the seat at your back, all of it conducting a quiet survey of your motion and reporting back to you a number you never see but always know. You know when you are moving. You know, roughly, how much. And for most of the time that human beings have been walking around and throwing things and sailing over water, that felt like enough. You knew how fast. You knew how to add speeds, the way you add simple things. If you're on a boat going 10 and you throw a stone forward at 15, the stone goes 25 relative to someone standing still on the shore. This seemed too obvious to question. The stone is going 10 because the boat is going 10, plus 15 because of your arm, and the answer is 25. It did not seem like the kind of thing that needed proof. This turns out to have been an assumption, a large, quiet, entirely understandable assumption, and like most large, quiet, understandable assumptions, it held perfectly for an extremely long time, right up until the moment it did not. What this chapter is interested in is not the moment the assumption broke. That moment comes later, in a different chapter, in a different key. What this chapter is interested in is what happens before the question exists, because there is a version of you that does not yet know there is anything to wonder about. You are moving, things move, speed adds. Light is fast, obviously, remarkably fast. Too fast to measure by hand, too fast to clock with a candle on a hillside, though people tried. And the universe seems like a place where faster is just more of the same thing, where the difference between a person walking and a comet is a difference of degree, not a difference of kind. That version of you is not wrong to feel this way. That version of you is standing in a tradition of physical intuition that goes back as far as thinking goes. Motion is motion. More motion is more. Less motion is less. Zero motion is standing still. It is a clean picture, and clean pictures tend to feel true. The part that breaks is so specific, so local to one thing in the universe, that when it was first discovered, the instinct was to assume the measuring instruments were wrong. Not the picture, the instruments. Speed, understood simply, is distance divided by time. You go a certain distance, and it takes a certain amount of time to do it, and the ratio between those two things is your speed. This is not a definition that requires any background. You carry it. It is the kind of knowledge that lives in its body before it lives in language. A runner knows it. A child on a bicycle knows it. You knew it before you had a word for it. Distance per unit of time. The number that comes out of that division is a speed. Now hold the simplicity of that for a moment. The reason it matters is that inside that simple definition, there is a hidden assumption that almost nobody notices because it does not seem like an assumption at all. It seems like a description of how reality is shaped. The assumption is that time runs at the same rate for everyone doing the measuring. The assumption is that a second is a second is a second, and that if you and someone else both have functioning clocks, and you both measure the time it took for something to travel a certain distance, you will both get the same answer. The assumption is that time is background, neutral, steady. The container inside which all motion happens, not a participant in that motion, not something that can be affected by how fast you or the thing you are measuring happens to be going. This assumption is wrong. Not slightly wrong. Not wrong under exotic conditions too extreme to encounter, but structurally wrong. Wrong in the same way a map is wrong when it has the continents in the right shape, but the distances between them off by a factor that only reveals itself on very long journeys. For ordinary motion, a car, a plane, a satellite, the wrongness is too small to register, smaller than any clock you own could detect. But the wrongness is there. It is in the structure of how time works, and it does not care whether the clocks are good enough to show it. The thing that is doing the limiting it helps to understand is not a rule that was added. Nothing decided that the universe should have a maximum speed, the way a road has a posted limit. There was no moment at which the physics was finalized and a ceiling was set. The ceiling is what falls out when you take the actual structure of space and time and follow it honestly without the assumption that time is a steady container. When you drop that assumption, when you actually take seriously the idea that time and space are not independent of the motion but involved in it, a number appears, a specific, particular, non-negotiable number. And everything that the universe contains, every particle, every wave, every form of energy that moves through anything, finds itself unable to cross it. The number is not a law, it is more like a consequence, but we are not yet at the consequence. This chapter is still early, still in the time before the question fully forms, still at the edge of the place where what you knew starts to feel slightly less than complete. The ceiling is there. It has always been there. You have never come close to it, and neither has anything you have ever touched. Think about the last time something moved fast enough that you genuinely registered the speed as fast. Not fast in the way that a car on a freeway is technically fast, where you have habituated to it so thoroughly that the sensation is just normal driving. Fast in a way that actually arrived in the body as information, a ball you did not expect, a car too close on a road, something falling from a shelf. The body has a response to that kind of fast. It is old. It is wired in at a depth that language does not reach. The response is not understanding. The response is just, this is moving, and I should account for it. Now consider that the fastest thing you have ever seen with your eyes was almost certainly light. Not light from a laser or an experiment, just light. The light that turned on when you flipped a switch. The light that came through a window when a cloud moved. That light was already going at the number that has never been exceeded, that nothing in the history of the universe has surpassed, that sits at the top of all possible motion like a fact that simply does not care whether it is believed. And you saw it and had no sensation of speed at all. The sensation was just light, present, already arrived. The speed was so thoroughly beyond anything the body's wiring was built to register that the body did not register it as speed. It registered it as instantaneous. It was not instantaneous. It had a speed, and that speed was the number, and the number is the ceiling, and the ceiling is what this series is quietly about. But you already knew somewhere that something about this was not finished. What the light was doing. While you were not looking, the light has already crossed the room by the time you notice it. Not crossed it slowly. Not crossed it in a way that took any detectable portion of a second. From your position on the bed, or the couch, or wherever you are horizontal right now, the light from the lamp or the screen or the sliver under the door arrived at your eye so completely without duration that the arrival and the source feel like the same thing, simultaneous, as if the lamp and your retina are simply connected rather than separated by distance, and the fastest thing in the universe travelling across it. That feeling of simultaneity is the thing worth staying with. Not correcting it yet, just staying with it. There is something specific about the way light moves that took an embarrassingly long time to establish, and the embarrassment is not incidental. It points at something real about how poorly suited human perception is for detecting what light actually does. The first serious attempt to measure the speed of light used 2 hills and a lantern. Ole Rømer did not use hills. That was Galileo, who tried and failed because the speed was too fast for the timing method available to him, which was a human finger on a clock and a human eye on a distant light. Rømer used something else. He used the moons of Jupiter. What Rømer noticed in 1676 was that the moon Io did not appear from behind Jupiter on schedule. It was late, not randomly late, predictably late, and predictably late in a pattern that correlated exactly with how far the Earth happened to be from Jupiter at any given time. When the Earth was on the far side of its orbit moving away from Jupiter, Io ran behind. When the Earth was closer, swinging back, Io caught up. Rømer understood what this meant. The light carrying the news of Io's emergence had farther to travel when the Earth was farther away, and it took longer, and the lag was the light's travel time accumulating across the extra distance. He got a number. The number was wrong by about 25%, because the diameter of Earth's orbit was not yet measured precisely enough. But the method was sound, and the principle was settled. Light takes time. Not a little time that rounds to 0, measurable time. Distance divided by a finite speed. This seems obvious now. It did not feel obvious then. The reason it did not feel obvious is the same reason the room feels like the light and the lamp are simply connected. At human scales, at room scales, at the scale of a city or a country, or even the distance between the Earth and the Moon, the time light takes to travel is so small that it falls entirely outside the range of anything the body can register as a gap. The Moon is roughly 384,000 kilometers away. Light covers that distance in about 1.3 seconds. You would not notice 1.3 seconds if you were having a conversation with someone on the Moon, not consciously, not as a felt delay, not as anything other than a slightly strange pause that might be attributed to a bad connection. The sun is about 8 light minutes away, meaning the light arriving at your window right now, if it is daytime, if the sun is up, left the surface of the sun 8 minutes ago. You're not seeing the sun as it is. You're seeing it as it was 8 minutes ago. This fact is accurate. It is also completely invisible to experience. The nearest star beyond the sun is about 4.2 light years away. The light arriving from it tonight left it roughly 4.2 years ago, not as a metaphor, not approximately. The photons entering your eye from that star, if you are in the right hemisphere and looking at the right patch of sky, departed from their source sometime around 4 years back and have been travelling at the maximum speed the universe permits ever since, and they are only now arriving, only now completing a journey of about 40 trillion kilometres, which took them the full 4 years to cover at a speed that would cross this room so many times per second, the number is not useful to think about. The light is always old. Every source of light you have ever seen has been giving you the past, not the present. The gap is usually too small to matter, but the gap is never zero. Orbit back to the room. You're still in it. The lamp is still on, or the screen is still lit, or the dark is the particular dark of a room where some light is leaking in from somewhere, and all of that light, every photon currently touching your eye, left its source at a specific moment in the past and has been moving at 299,792,458 meters per second ever since. That number is not an approximation. It is the defined value of the speed of light in a vacuum, and since 1983 it has actually been used to define the meter itself, meaning that the meter is no longer independently defined and then used to measure the speed of light. Instead, the speed of light is fixed, and the meter is whatever length makes that number come out right. The speed became the anchor, everything else adjusted. That is a strange thing for a speed to be. Most speeds are descriptive. They tell you how fast something happens to be going. The speed of light is definitional. It is built into the measuring system so deeply that changing it would require changing what a meter means. It is not a thing that was measured and recorded. It is a thing that was measured, found to be invariant, and then promoted to the foundation. Invariant is the word that matters here. It means the same regardless of who measures it, regardless of how fast the measurer is moving, regardless of the direction of measurement, regardless of the speed of the source. If you are standing still and a light source passes you at half the speed of light, the light from that source still reaches you at 299,792,458 meters per second, not faster. If you are moving toward the light source at half the speed of light, the light still reaches you at the same number, not faster. The speed does not add. It does not stack. It arrives the same way regardless of the motion of anything involved. This is the thing that does not feel right. Come back to the hills and the lantern for a moment, not Roma's moons. The earlier attempt, the human one. The one with 2 people on 2 hills with lanterns and shutters, and the plan to measure the delay between one person uncovering their light and the other person seeing it. The plan was simple. Person A uncovers their lantern. Person B, on the distant hill, sees the light and immediately uncovers theirs. Person A measures the time between uncovering their own lantern and seeing Person B's response. Subtract the human reaction time, and you have the travel time of light twice, there and back. Measure the distance between the hills, divide, and you have the speed. Galileo, or people working in his tradition, tried versions of this. The hills were too close. The speed was too fast. The delay was shorter than any human nervous system or mechanical clock of the era could detect. The experiment came back with nothing, or rather, with the unsatisfying result that light appeared to travel instantaneously, which no one quite believed but could not yet disprove at terrestrial distances. What is worth holding on to from that failed experiment is not the failure. It is the design. The design assumed that if you could just get your clocks fast enough and your hills far enough apart, you would eventually catch light in the act of taking time. The assumption was that light has a speed, it just needed bigger distances to show itself. That assumption was correct. What nobody in that tradition was prepared for was what would happen when the speed was finally measured carefully enough to be used in calculations. The discovery that the speed did not behave like other speeds, that it refused to add, that it sat at the same value regardless of the motion of the thing producing it or the thing receiving it. That refusal is not incidental. It is, it turns out, the whole thing. Orbit again. Come back to the room, to the light arriving without apparent delay, to the feeling that the lamp and the eye are simply connected. That feeling is not entirely wrong. It is a reasonable description of what the experience is like. The wrongness in it is not the felt simultaneity. The light genuinely arrives faster than any human process can register as a gap, but the implication the feeling carries, which is that speed, for light, works the way speed works for everything else. That if you could just get fast enough yourself, you could catch up. That the gap between you and the light could, in principle, close. It cannot. Not because light is very fast and you are very slow, though that is also true, but because the structure of the universe is such that the gap between you and a beam of light is not a gap that motion can close. You can get faster. The light does not get relatively slower. The number stays the same. The distance between you and the wavefront does not shrink the way the distance between you and a running person shrinks when you run after them. This is the part that requires sitting with, not because it is difficult to say, because it is difficult to actually believe. There is a version of this chapter that would now explain why. That would move from the strangeness of the constant speed to the mechanism behind it, to the geometry of space-time, to the reason the number is what it is. That version would be moving too fast. The thing to stay with, for now, is just the fact of the arrival. The light came from there and is now here. It took a specific amount of time to do that, a time so short it did not feel like time at all, and the speed it travelled at, the only speed it could have travelled at, the speed that is the same for every observer in every state of motion in every corner of the universe, is a number that sits at the top of all possible motion and does not move. The room is still quiet. The light is still arriving. It has been arriving at that speed from every source you have ever seen your entire life, and you registered none of the travel time, and the universe did not require you to. But the travel time was there. It is always there. The problem nobody knew was a problem. There is a moment just before a measurement comes back wrong when everything is still fine. The equipment is set up. The calculation is ready. The scientist, or the team, or the one person in a cold room with a notebook, is waiting for a number, and the number they are waiting for is the number they expect, because the number they expect is the number the theory predicts, and the theory has worked every other time, has worked for generations, has worked so consistently and so completely that expecting it to fail now would require a specific kind of stubbornness that most careful people do not carry into a laboratory. The experiment is a confirmation. That is what it is supposed to be. That is what almost everyone who has ever run an experiment of this kind has understood themselves to be doing. Confirming. And then the number is wrong. To understand why the wrongness was so hard to accept, it helps to understand what the experiment was trying to confirm and why confirming it seemed, at the time, like a reasonable thing to spend money and effort on. By the late 19th century, physics had a picture of waves, not a vague picture, a detailed, mathematically precise, experimentally verified picture of how waves move. Waves need a medium. Sound waves need air, or water, or something solid to compress and rarefy. Ocean waves need water. Waves, in the physical understanding of the 1880s, were disturbances in something, and the something was necessary. Not as a technicality, but as the mechanism. The wave was the medium moving. Take away the medium, and you take away the wave. Light was understood to be a wave. James Clerk Maxwell had shown this in the 1860s with a set of equations that unified electricity and magnetism and produced, as a consequence, a wave travelling at a speed that matched the measured speed of light, so precisely that the conclusion was unavoidable. Light was an electromagnetic wave. The equations were beautiful, were correct, have remained correct to this day in every domain where they apply, which is nearly every domain that is not quantum and not relativistic. But if light was a wave, it needed a medium. The medium was called the luminiferous ether. Luminiferous, light-bearing. Ether, the substance that the universe was, it was believed filled with, the substrate through which light propagated the way sound propagates through air. Nobody had detected the ether directly. Nobody had touched it or measured it or found its density or its viscosity. But it had to be there. The wave required it. And if it was there, filling all of space, then the Earth was moving through it, orbiting the Sun at roughly 30 kilometers per second, and that motion should be detectable. This is where the sediment begins to settle. The logic was clean. If the Earth moves through the ether, and light travels through the ether at a fixed speed relative to the ether, then the speed of light measured on Earth should depend on direction. Light travelling in the direction of Earth's motion should appear to move slightly slower relative to the Earth. You are chasing it, in a sense, and it has a smaller relative speed. Light travelling against Earth's motion should appear slightly faster. It is coming toward you, and you are moving toward it. Light travelling sideways should be somewhere in between. The difference would be small. The ratio of Earth's orbital speed to the speed of light is about 1/10,000th, but it would be there, measurable, a signature of the ether wind. Albert Michelson built an instrument to find it. Then he improved it. Then he enlisted Edward Morley, and together they ran an experiment in 1887 that was, by the standards of the time, almost absurdly precise, sensitive enough to detect a difference 1/40th the size of what the ether theory predicted. The difference was not there, not too small to measure, not within the margin of error, not reduced from what was expected, not present at any level the instrument could find, and the instrument could find very small things. The speed of light was the same in every direction. The ether wind left no signature. The Earth's motion through the supposed medium did not produce the shift that the medium's existence required. Here the rhythm slows. Michelson did not celebrate this result. He was, by several accounts, disappointed by it. The experiment that would eventually carry his name toward a Nobel Prize and toward a permanent place in the history of physics was to him a failure. He had built the instrument to find the ether wind, not to disprove it. The absence of a signal was not the answer he was looking for. He ran the experiment again. The absence persisted. Others tried to explain it away. George Fitzgerald suggested that maybe objects physically contract in the direction of motion through the ether, just enough to cancel out the expected difference. Hendrik Lorentz developed this mathematically. The contraction was real, in the sense that the equations worked, but it required the ether to be doing something to matter that passed through it. Something with no independent evidence, something that existed solely to rescue the theory from the measurement. The measurement sat there. It did not care about the rescues. What is being laid down here, quietly, is not just the story of one experiment. It is the story of a picture of the universe that was complete and consistent and correct in almost every particular, encountering the one thing it could not absorb. The ether theory was not sloppy thinking. It was careful thinking applied to a genuinely puzzling phenomenon, the propagation of waves through what appeared to be empty space. And it produced a testable prediction, and the prediction failed, and the failure was clean. The picture had a crack in it. The crack ran through the most basic assumption about motion, that speeds add, that the speed of something is always relative to something else, that there is no absolute speed, only speeds measured against particular reference points. If the ether existed, it would be the one fixed reference point, the one thing against which all motion could be measured absolutely. The experiment was not just testing the ether, it was testing the idea of a universal reference frame, and the test came back saying, there is not one. If there is no universal reference frame and the speed of light is the same for everyone regardless of their motion, then something has to give. Either the speed of light is not actually a fixed number, which the experiments kept refusing to support, or the things used to measure speed, namely distance and time, are not the fixed neutral containers they appeared to be. Distance and time had always seemed like the givens, the things you measured other things against, the background, the frame. They were not the frame. The experiment was run again and again and again in different years by different people with progressively more sensitive equipment. Each time the result was the same. The speed of light did not shift with Earth's motion. It did not depend on direction. It arrived at the same value whether the Earth was moving toward the source or away from it, or sideways to it. The number was invariant. And what invariant means in this context is not just consistent or reliable or reproducible. It means immune to the motion of the observer. It means the same number falls out of the calculation regardless of how fast the person doing the calculation is moving, regardless of how fast the source of the light is moving, regardless of anything about the state of motion of the system doing the measuring. This is the thing the 19th century had no framework for, not because the 19th century was unsophisticated. It was extraordinarily sophisticated, but because the result requires abandoning something that feels less like an assumption and more like a definition. The idea that time passes at the same rate everywhere, for everyone, is not a hypothesis most people in 1887 would have recognized as a hypothesis. It was furniture. It was so built into the structure of how physics was done that it did not appear in the list of things that could be wrong. The measurement said it was wrong, not loudly. The measurement did not come with an explanation. It came with an absence, the absence of the expected signal, and left the framework intact but cracked, producing results that fit no theory anyone currently had, waiting quietly in the literature for someone to come along and take the absence seriously rather than explaining it away. That someone was 17 years away. The problem with a problem that nobody knows is a problem is that it takes an unusual kind of mind to see it. Not more intelligent necessarily, not more educated, just less attached to the furniture, less willing to treat the frame as given, willing to ask without embarrassment whether the thing everyone has been measuring with might itself be the thing that is off. The crack in the picture was not in the data. The data was fine. The crack was in the assumption underneath the data. The assumption that had never been named because naming it had never seemed necessary. Time is time. A second here is a second there. Clocks agree. Motion is relative, yes, but time is not. Time is the one thing you can count on to behave, except it doesn't. That is the next layer, and it settles differently than the ones before it. A number that did not ask permission. Start with the number itself, 299,792,458 meters per second in a vacuum, not approximately, not rounded, not a working figure that gets refined as instruments improve. That is the number. It is exact in a way that almost no physical quantity is exact, and the reason it is exact is strange enough to deserve its own moment before anything else gets said about it. Most constants in physics are measured. You run an experiment, you get a value, you run it again with better equipment and the value gets more precise. The constant sits out there in reality, waiting to be pinned down more accurately each generation. There is always a margin, always a last digit that wobbles slightly depending on the method. The speed of light used to be like that. Then, in 1983, the international body responsible for such things made a decision that sounds bureaucratic and is actually quite strange. They fixed the speed of a light by definition. They set it at exactly 299,792,458 meters per second, with no uncertainty, and then redefined the meter to match. The meter became the distance light travels in exactly 299,792,458 792,458th of a second. The speed stopped being something measured and became something decreed, not arbitrarily, but because the measurements had converged so tightly, and the constancy of the speed had been so thoroughly verified that the uncertainty in the speed of light had become smaller than the uncertainty in the physical platinum iridium bar that used to define the meter. So they swapped the anchor. The speed became the definition. The meter became the derived unit. This means that right now, tonight, if you wanted to measure the speed of light, you could not get a wrong answer. The wrong answer is not available. The experiment would tell you how long your meter sticks are, not how fast light goes. The speed of light is no longer a fact about light. It is a fact about measurement. It is built into the ruler. I'm not entirely sure what to do with that. I will say it plainly. This fact sits in a strange place in my understanding, somewhere between a technicality and something that matters a great deal, and I have not fully resolved which one it is, but sit with it. A speed that is not measured but defined. A ceiling that is not observed but constitutive. The number has a name. C, just the letter, lowercase, italic in print. Every equation in special relativity that contains a speed limit contains C. Every calculation about how much energy is stored in matter, E equals mc squared, the most recognized equation in the culture, the one that appears on posters and tattoos and the covers of magazines, contains C. The energy locked inside a kilogram of anything is that kilogram multiplied by C multiplied by C again, multiplied by roughly 90 quadrillion. The reason mass contains so much energy is that C is so large. The number is not just a speed. It is a converter between mass and energy, between space and time, between things that seemed separate and turned out to be the same thing in different units. C is not a speed that matter happens to reach under certain conditions. C is a structural feature of the universe that shows up in every domain where fast things or energetic things or relativistic things are involved. It appears in the equations governing how stars burn, how particles interact, how black holes form, how the early universe expanded, how clocks on satellites have to be corrected to keep GPS working. It is everywhere. It is not a property of light specifically. Light travels at c because light has no mass. Any massless thing travels at c. Light just happens to be the massless thing we encounter most often. The speed limit is not about light. Light just lives at the limit because it has no choice. Here is the part that requires the body. Imagine you are pushing something, not light, something with mass, a box, a ball, a particle in an accelerator. The scale does not matter. You apply force. The thing speeds up. You apply more force. It speeds up more. This is Newton. This is the world as it presents itself at ordinary speeds. Force produces acceleration. More force produces more acceleration. The relationship is clean and proportional, and feels like it should extend indefinitely. Keep pushing and the thing keeps getting faster, without limit, until eventually if you push long enough, you could get it to any speed you like. You cannot. As the thing gets faster, it gets harder to accelerate, not because of friction, not because of any force pushing back, because of something that happens to the relationship between force and velocity as velocity approaches c. The object behaves, from the perspective of the force being applied, as if it is getting heavier. Not physically heavier in the everyday sense. Its rest mass does not change. But its resistance to further acceleration grows. and it grows in a way that is precisely described by the same factor that describes time dilation and length contraction. The closer the object gets to C, the more energy is required to push it any faster, and the return diminishes towards zero as the speed approaches the limit. To reach C exactly, an object with any mass at all would require infinite energy. Not a very large amount. Infinite. The curve of required energy approaches a vertical line at C and never crosses it. This is not a practical limitation in the sense of needing a bigger rocket. It is a mathematical wall. The equation produces an infinity, and infinities in physics are usually the universe's way of saying, this configuration does not exist. The thread this chapter is following is thin. It goes, the number exists, the number is exact, the number is built into the structure of measurement, the number appears everywhere, the number cannot be reached by anything with mass. Follow it one step further. If C cannot be reached, and if the equations say that reaching C would require infinite energy, then the question that sits just at the edge of this is, why does the universe have this particular number and not a different one? Why 299,792,458 meters per second, and not twice that, or half? The honest answer is, we do not fully know. The number falls out of Maxwell's equations for electromagnetism. It is the square root of a ratio between two other constants, the permittivity of free space and the permeability of free space. And those constants describe how strongly electric and magnetic fields interact with the vacuum. In that sense, C is determined by the electromagnetic properties of empty space. Change those properties and C would change. But why those properties are what they are, why the vacuum has the particular electromagnetic character it has, that is a question that currently points toward physics that does not yet fully exist. The number is exact. The number is everywhere. The number is a wall. Why it is this wall and not another, the universe has not said. What space does when nothing is watching. Start far enough away that the Earth is a point, not a metaphor, an actual exercise in scale. Back away from where you are right now, through the ceiling, through the atmosphere, out past the moon, and past Mars, and past the cold outer planets, and past the Oort cloud, and into the space between stars. Keep going. Far enough that the sun is just another point of light among the several 100 billion points of light in this galaxy, and the galaxy itself is a smear, a shape, an object with edges and a center, and a particular orientation in the space around it. Far enough that the galaxy is small. Now look at the space between things. There is more of it than there is of anything else. The universe is, overwhelmingly, a structure made of distance. The matter, all the stars and planets and gas and dust and everything that has ever been touched or measured or seen, is a rounding error in the total volume. What the universe mostly is the space between things, and for a long time that space was understood to be background, a container, a coordinate system, the place where things happened, not a thing in itself. This chapter is about why that understanding had to go. Move closer, not back to Earth, to something in between. Pick a point in intergalactic space, somewhere between two galaxy clusters, in a region where the density of matter is so low that you could travel for millions of light years without encountering a single atom. Nothing is happening there in the way that anything you could touch or see happens. no light sources nearby, no gravitational wells significant enough to bend a path, just space, extending in all directions, the same in every direction, as empty as anything in the universe gets. That space is not doing nothing. It has a geometry. Not a geometry in the loose metaphorical sense of having a shape, a geometry in the technical sense, meaning that the relationships between points in that space, the distances, the angles, the way parallel lines behave, follow rules. In flat space, space with no mass nearby to curve it, those rules are Euclidean, the geometry of a high school classroom. Parallel lines stay parallel. The angles of a triangle add to 180 degrees. The shortest distance between 2 points is a straight line. But the geometry is there whether or not anything is in the space to measure it. The rules of distance are a property of the space itself, not of the things that might happen to be passing through it. This is the first layer of what it means for space to be something rather than nothing. Move closer again. Now add motion. Put two objects in this empty space. Give them a relative velocity. They are moving apart or toward each other, and in the framework that works for everyday physics, the framework Newton built, the framework that handles every calculation from thrown balls to orbiting planets, the velocity between them is simply the velocity between them, measured in units of distance per unit of time, and those units are fixed, and the measurement is the same for any third observer watching from outside the system, except the Michelson-Morley result, which settled into the physics literature in 1887 and refused to be explained away, required a framework where this was not quite true, where the measurement was not the same for every observer, where something about the measuring process itself changed with motion, changed in exactly the right amount to keep the speed of light constant for everyone. Einstein's special relativity, published in 1905, was the framework that made the required geometry explicit. What special relativity said about space and time was not that they were strange or paradoxical or defying common sense. What it said was geometrical. Space and time are not separate things. They are two aspects of a single four-dimensional structure called spacetime. And the geometry of spacetime is not Euclidean. It follows different rules. Rules in which the invariant quantity, the quantity that every observer agrees on regardless of their motion, is not distance and not time, but a combination of the two called the space-time interval. In the geometry of space-time, the speed of light is not a speed that light happens to travel at. It is a feature of the geometry, the slope of the light cone. The angle that light traces through space-time is fixed by the structure of the space, the way the angles of a Euclidean triangle are fixed at 180 degrees. You cannot change the angle by moving. You cannot change it by accelerating. The geometry is what it is, everywhere, always, and C is what falls out of it. This requires staying with, so stay with it. In ordinary space, 3 dimensions, Euclidean, the space of rooms and roads and the distances between cities, the distance between 2 points is calculated one way. Square the differences in each coordinate, add them, take the square root. This is the Pythagorean theorem extended to 3 dimensions. Every observer with a correctly calibrated ruler gets the same distance. Distance is invariant. In space-time, the calculation is different. You include time, but time enters with a minus sign. The space-time interval between 2 events is not the sum of squared differences. It is the square of the time separation minus the sum of squared spatial separations times c squared. The minus sign is everything. It is what makes the geometry of space-time different from the geometry of ordinary space in the way that matters, and it is what produces the invariant speed. Set the space-time interval to 0. This means two events are connected by a path through space-time with 0 interval. Solve for what speed of travel produces a 0 interval. The answer is c, exactly c, only c. Light travels along paths of 0 space-time interval. These are called null geodesics. For light, the space-time distance between any 2 points on its path is always 0, regardless of how much ordinary space it has crossed, regardless of how much time has passed in the outside world. Light does not age. It does not experience duration. Between emission and absorption for the photon, there is no interval at all. For anything with mass, the space-time interval is not 0. It is real, positive, and it represents the proper time experienced by the object along its path. The time its own internal clock records, the time that shows up as age, and the geometry of space-time is such that the path which maximizes proper time, the path on which you age the most, experience the most time, is the path on which you move the least through space. Sitting still in your room, you're traveling through time at the maximum possible rate. Every meter per second you add to your spatial velocity is a meter per second diverted from your time velocity. You cannot go faster than c through space-time in total. You're always going at c through space-time. You're trading time speed for space speed. When you're stationary, all of it goes to time. When you approach c spatially, almost none of it goes to time. The speed limit is not a restriction placed on things moving through space. It is a consequence of how space-time is shaped. You're already moving at the maximum speed. You just have a choice about which direction most of it goes. Move back out, past the galaxy, past the clusters, into the deep intergalactic space where nothing is, where the geometry of space-time sits undisturbed and empty and doing its quiet work with no witnesses. The space between things is not doing nothing. It has a geometry. The geometry has a preferred angle. The angle is c. It was there before anything moved through it. It will be there after everything that is currently moving has stopped. It does not require matter to be present in order to be a property of the space. It is, in some sense that is, very hard to put plainly, prior to everything that happens inside it. Light, fast, space, shaped, the shape, before everything else. Clocks that lie truthfully. The experiment is already over. 2 clocks have been compared. The comparison did not come out even. This is not a thought experiment anymore. This has been done. In 1971, Joseph Haefel and Richard Keating put 4 cesium atomic clocks on commercial aircraft, flew them around the world in both directions, eastward and westward, and then brought them back and compared them with reference clocks that had stayed on the ground at the US Naval Observatory. The clocks that had flown disagreed with the clocks that had stayed. Not randomly, not due to malfunction, not due to measurement error. They disagreed by specific amounts that matched specific predictions from special and general relativity to within the experimental uncertainty. The clocks had been moving. Moving clocks run slow. This is not a malfunction of the clocks. It is not a metaphor about perception. It is a fact about the structure of time. Back up slightly before the clocks. to the idea that requires them. Time dilation is what special relativity calls the phenomenon of moving clocks running slow. The word dilation means widening, stretching. The intervals between ticks stretch when the clock is moving, so that a moving clock that ticks, say, once per second in its own frame ticks less than once per second, as measured by a stationary observer watching it go by. The faster the clock moves, the wider the stretch, the more the ticks spread out, the closer to C, the slower the tick. At everyday speeds, the effect is present but minute. A clock on a passenger aircraft moving at about 900 kilometers per hour runs slow by roughly a few nanoseconds per hour compared to a clock on the ground. A nanosecond is a billionth of a second. The effect is real and measurable only because atomic clocks are accurate enough to detect nanoseconds. At human speeds, without atomic clocks, time dilation is invisible, not because it is not happening, but because nothing we have built outside of atomic clocks is sensitive enough to show it. At speeds approaching C, it is not invisible. At 87% of C, a moving clock runs at half the rate of a stationary one. At 99% of C, a moving clock runs at about 1/7 the rate. At 99.9% of C, roughly 1/22nd. The relationship is not linear. It follows a curve, the Lorentz factor, usually written as the Greek letter gamma, and the curve goes gently at first, and then bends steeply upward as C approaches, so that the last few percent of the speed limit produce dramatically more dilation than the first 90% combined. Here the rhythm slows. Consider what it means for a clock to run slow. Not just a mechanical clock, not just an atomic clock, any clock, including the clock inside a living cell that governs how fast proteins fold and reactions complete, including the clock in a nervous system that determines the rate of thought, including the aging process itself, the accumulated biochemical record of time passing that writes itself into cells and joints, and the length of telomeres. A clock is anything that repeats. A heartbeat is a clock. A breath is a clock. The oscillation of a cesium atom is a clock. When special relativity says that moving clocks run slow, it means all of these. Every periodic process, every rhythm, every cycle. The person on the fast-moving ship ages more slowly, not experientially. From inside the ship, nothing feels different. The heartbeat feels normal. Thoughts arrive at their normal rate. The clocks on the wall tick at what feels like a second per second. But from outside the ship, from the frame of someone watching it pass, every process on that ship is stretched. Every second on the ship corresponds to more than 1 second outside it. Both observers are right. There is no frame that is more correct than the other. The pulse of this chapter expands again. The thing that makes time dilation genuinely difficult to absorb is not the math. The math is manageable once you have the Lorentz factor. The difficult thing is the implication about simultaneity, about what it means for two things to happen at the same time. In Newtonian physics, simultaneity is absolute. If two events happen at the same time, they happen at the same time for everyone. There is no ambiguity, there is no frame dependence. Two lightning bolts striking at the same moment are simultaneous for every observer in the universe. In special relativity, this is not true. Whether two events are simultaneous depends on the observer's state of motion. Two events that are simultaneous in one frame are not simultaneous in a frame that is moving relative to the first. The time ordering of spatially separated events can change between frames. What one observer calls before, another observer, moving relative to the first, might call after. This is not a matter of light travel time causing apparent differences. It is a structural feature of how time and space mix under the Lorentz transformation. The only events whose time ordering is preserved across all frames are events connected by cause and effect, events where one can influence the other, and the reason their ordering is preserved is that they are connected by something travelling at or below c. A cause cannot reach its effect faster than c. If it could, you could construct a frame in which the effect preceded the cause, which would allow a consistent physical description of an effect with no cause, which the structure of the universe does not permit. The speed limit and the consistency of causality are the same requirement. They are not two separate rules. They are the same rule expressed differently. Come back to the clocks. Haffel and Keating's clocks came back from their circumnavigation with a discrepancy. The eastward clocks, moving faster relative to the Earth's centre, because the aircraft's speed added to the Earth's rotation, ran slower due to velocity time dilation. The westward clocks, moving slower relative to the Earth's centre, because the aircraft's speed worked against the rotation, ran faster due to velocity time dilation. Both effects were also partially offset and complicated by gravitational time dilation. Clocks at altitude run faster because they are higher in a gravitational field, a consequence of general relativity, and the final comparison required accounting for both contributions. The predictions matched the measurements. The clocks that had travelled came back telling a different time than the clocks that had stayed home, not because they had drifted or been jostled or been affected by vibration, because they had genuinely experienced a different amount of time. Time had passed at different rates in different places for different clocks, moving at different speeds. Both clocks were right. What is left when the experiment is done, when the clocks have been compared, and the discrepancy recorded, and the textbooks have noted the confirmation, is something quiet and slightly vertiginous. You have your own clock. It is your heartbeat and your metabolism and your neurons and your aging. It is running right now at the rate it runs for something at your speed, in your gravitational environment. Someone moving much faster than you is running slower. Someone much higher than you in a gravitational field is running faster, not experiencing it differently, running differently, accumulating different amounts of elapsed time genuinely, in a way that would be measurable if you compared the records afterward. Every clock is accurate. Every clock tells the truth. The truths do not agree. That is not a paradox. It is the geometry. But it takes a long time to feel like it is not a paradox. The traveller who never comes back the same age. You know this one. You have heard the name twin paradox, the version where two people start at the same age and do not end that way. Except here is the thing about calling it a paradox. It is not one. It was called a paradox early in the history of relativity because it seemed to contain a contradiction, and the name stuck the way names tend to stick even after the confusion is resolved. The way a street keeps its name after the person it was named for is forgotten. The twin paradox is not a paradox. It is a result. Let us follow the thread of it. Two people, same age at the start. One stays, one goes. The one who goes boards something fast, not fast in the way we are used to using that word, but genuinely fast, a significant fraction of c, fast enough that the Lorentz factor is meaningful, fast enough that the time dilation it produces is not nanoseconds but years. Say the traveller goes at 87% of c, the speed at which the Lorentz factor is exactly 2, meaning that for every 2 years that pass at home, 1 year passes on the ship. The traveller goes for what feels on the ship like 5 years, then turns around, then comes back for what feels on the ship like another 5 years. The traveller's clock, the traveller's body, the traveller's cells and heartbeats and accumulated experience, all of it records 10 years of elapsed time. The person who stayed has aged 20 years. They are standing at the same place they started, looking at each other, and one of them is 10 years older than the other, not 10 years more tired, not 10 years more experienced, 10 years older in the cellular sense. 10 years more of time has passed inside one body than inside the other. The question that makes this feel like a paradox, the one that got it the wrong name, is this. If motion is relative, why is it the traveller who ages less and not the person who stayed home? From the traveller's perspective, wasn't the home person the one who moved away and came back? The answer is that the situations are not symmetric. The traveller accelerated. The traveller turned around. Acceleration is not relative the way constant velocity is relative. The traveller can feel the turn. The home person cannot. There is a physical, measurable, felt distinction between the two paths through space-time. The traveller's path is curved, involves a change of direction through space-time, and it is precisely this curvature that makes the traveller's total elapsed time shorter. The deeper answer is geometric. In ordinary space, a straight line is the shortest distance between 2 points. In space-time, a straight path, no acceleration, no turning, is the path of maximum proper time. The traveller, by accelerating and changing direction, took a curved path through space-time. The home person took the straight one. And in space-time geometry, the curved path accumulates less proper time than the straight path between the same two events. The traveller went the long way through space. They went the short way through time. What I find genuinely strange about this, and I want to say strange rather than anything more composed because that is what it is that this has been experimentally confirmed, not with twins, who have not been sent on relativistic spacecraft, but with particles. Muons are produced in the upper atmosphere when cosmic rays, high-energy particles from space, collide with air molecules. Muons are unstable, they decay. Their half-life is about 2.2 microseconds. At the speeds they travel, typically above 99% of c, they should, by naive calculation, decay before reaching the Earth's surface. The distance from the upper atmosphere to the ground is too far for a particle living only 2.2 microseconds to cover, even at near light speed. But they do reach the surface in large numbers, in numbers consistent with a half-life not of 2.2 microseconds, but of many times that, because from the perspective of Earth, the muon's internal clock is running slow. The muon's 2.2 microseconds of proper time corresponds to many more microseconds of Earth time, enough for the muon to complete the journey. The muon ages more slowly. It makes it to the surface because of that. The surface detectors confirm it. The muon is the traveller. The Earth is the twin who stayed home. The muon arrives younger than it should be, if time were absolute and clocks agreed everywhere. The traveller comes back 10 years younger than their twin. The moon reaches the surface that its half-life said it should not reach. The atomic clocks on aircraft land showing a different time than the clocks that stayed on the ground. All of these are the same thing. They are all the geometry of space-time making itself visible in clocks and bodies and particle lifetimes. The speed limit is not incidental to any of this. The speed limit is the reason all of this has the shape it has. Without a maximum speed, the geometry would be different. Without a maximum speed, time dilation would not exist in the form it exists. The traveller would come back the same age. The muon would not reach the surface. The aircraft clocks would agree with the ground clocks. The 10-year gap between the twins is the speed limit, made biological, made personal, made into a body standing in front of another body and being a decade younger than expected, having travelled farther through space and less far through time, carrying the geometry of the universe in the difference between their ages, in the quiet physical fact of being undeniably not the same. There is something here, I'm not sure exactly what it is, that feels like it should matter more than we let it. The geometry is not abstract. It is written in how much time a body has experienced. It is in the cells. It goes all the way in. Why infinite energy is the wrong way to think about it. The explanation you may have heard goes like this. Nothing can reach the speed of light because doing so would require infinite energy. And since you cannot have infinite energy, you cannot reach the speed of light. It is a clean explanation. It even has a satisfying shape. The harder you push, the more energy you need, and the curve of required energy goes vertical at sea, forever out of reach. It is not wrong. It is also not the deepest answer, and the ways it falls short are interesting, because what it falls short of is more fundamental than the energy argument, and does not require talking about energy at all. Orbit around the explanation first. Feel where it holds. The Lorentz factor, gamma, appears in the relativistic expression for momentum. At low speeds, relativistic momentum is very close to Newtonian momentum, mass times velocity. The difference is negligible at everyday speeds and grows as velocity increases. As velocity approaches c, gamma increases without bound. And because the kinetic energy required to accelerate an object is related to the change in relativistic momentum, and because that momentum grows without bound as c approaches, the energy required to continue accelerating also grows without bound. The curve goes vertical. Infinite energy for the last step. This is accurate. Accelerators confirm it. The Large Hadron Collider accelerates protons to 99.9999991% of c. The energy required to push those last decimal places is genuinely enormous. The machine is 27 kilometers in circumference and uses more electricity than a small city. Each incremental increase in velocity close to c cost exponentially more energy than the last. The asymptote is real. But here is where the infinite energy framing starts to feel like a translation that has carried the meaning imperfectly. The energy argument is a consequence. It is not the cause. The reason infinite energy is required is not that c is a wall that needs to be broken through, the way a sound barrier needs to be broken through. It is because the geometry of space-time is such that the world line of a massive object cannot be rotated through any amount of acceleration, through any amount of applied force, to point in the direction of a light ray. The light ray's direction in space-time is a direction that massive objects simply do not have access to. It is not forbidden. It is absent from the geometry of their situation. Think of it this way. You are in a room. You can face any direction in that room. You can turn left, turn right, look up, look down. All of these directions are available to you. Now imagine there is one direction in that room that is not available to you. Not blocked, not locked, but simply not part of the set of directions a thing like you can point. You cannot access it no matter how many times you turn or how fast you spin. It is not that you need more turning energy. It is that the direction is outside the space of directions available to you. That is what C is for massive objects. Not a wall, a direction you cannot point. The infinite energy framing also obscures something about massless particles that the geometric framing makes clear. Photons do not travel at C because they have enormous energy. Some photons have very little energy. A radio wave photon has far less energy than a visible light photon, and far less than a gamma ray photon. Energy does not determine whether a particle travels at C. Mass does, or rather, the absence of mass does. A photon has no rest mass. It has zero rest mass exactly, not approximately. And it is this absence that means C is the only speed available to it. A massless particle cannot travel at any speed other than C. It does not travel at C because it has been pushed to the limit. It travels at C because C is the only speed that exists for something with its properties. This is the infinite energy argument's blind spot. It implies that C is a limit approached from below, a fence that energy pushes against. But for light, there is no approaching. Light does not start slow and get pushed faster. A photon is born at C. It has never travelled at any other speed. There is no threshold it crosses. What the geometric picture gives you that the energy picture does not is a reason. Not just a description of what happens. Energy required goes to infinity. But an account of why the structure of space-time produces this result. The space-time interval for a light-like path is 0, as established in the earlier chapter. The proper time along a light-like path is 0. A photon between emission and absorption experiences no duration, and the structure that produces this, the minus sign in the space-time metric, the specific way time and space combine in the interval, is also what produces the finite invariant speed. The 0 proper time and the invariant speed are the same geometric fact expressed two different ways. You cannot reach C because reaching C would mean your proper time went to 0. It would mean that from your own perspective, no time passes between events. It would mean you exist in a state that has no interior duration, no sequence of experiences, no before and after within yourself. For something with mass, this is not energetically expensive. It is geometrically prohibited. It is not a place on the energy curve. It is outside the space of possible states. The explanation I am less sure about, I should say plainly, is whether this geometric account itself is the deepest available, or whether it is a description of something that itself has a deeper account. The space-time metric is what it is. The minus sign is there. The invariant speed exists. But why this particular geometry and not another? Why the universe has the causal structure it has? Why the light cone is oriented the way it is? These are questions that go somewhere I cannot follow them completely. Special relativity describes the structure. It does not explain why the structure is this structure. The energy explanation is not wrong, it is a shadow. A correct shadow cast by the geometry onto the space of energies. The shadow looks like a wall. The actual structure is more like a shape, the shape of what space-time is, and C is not a barrier inside that shape, but a feature of the shape itself, the way the horizon is a feature of the Earth's curvature and not a wall standing on the surface. The horizon recedes as you approach it. C does not recede. It is not ahead of you. It is the edge of the kind of thing you are, the things that do not move through space at all. Some things are not in the race, not slower, not stationary in the ordinary sense, just out of it entirely, participating in the universe's motion budget in a way that is adjacent to speed but not described by it. Start with a photon, not its speed, its experience of the journey. A photon travels from a distant star to your eye. The distance in your frame is enormous, light years of space crossed in years of time. But the photon's proper time for this journey is 0, not nearly 0, not negligibly small, 0. Between emission and absorption, for the photon, there is no duration, no sequence of internal events, no tick of any internal clock. The photon does not travel through time. It exists at both ends of its journey simultaneously, in the only sense that is meaningful for something with 0 proper time. This is what it means to travel at sea, not to go very fast. To exit time. Photons are not the only massless things. Gluons, which carry the strong nuclear force binding quarks together inside protons and neutrons, are also massless. They also travel at sea. They also have 0 proper time along their paths. They live inside a proton, doing their binding work in a space so small it makes no practical sense to describe it as travel, but the formal description is the same. Massless. Speed c. 0 interval. Gravitational waves are different in character but share the relevant property. They propagate at sea. They were produced, in the event detected in 2015 by LIGO, by 2 black holes merging about 1.3 billion light-years away. The waves arrived here at Earth after 1.3 billion years of travel through space, but along their own path, in the only sense applicable to a massless disturbance in space-time. No time elapsed. A disturbance in space-time carrying information about 2 black holes colliding 1.3 billion years ago, experiencing no duration in the crossing. There is also a category that is not massless but that moves through space in a different way than matter does. Phase velocity. The speed at which the phase of a wave propagates, the rate at which a crest advances through a medium, can exceed c under certain conditions. In a waveguide in certain optical media, the phase velocity of a wave can be greater than c. This does not violate the speed limit. No information travels at the phase velocity. No energy travels at the phase velocity. The phase is a pattern, not a thing. The advance of the crest carries no signal and cannot be used to transmit a message. The relevant velocity for information and energy is the group velocity, which remains at or below c. The universe is careful about this distinction. Pattern can exceed c. Information cannot. The category of things that do not move through space at all also includes quantum entanglement, which is not a thing moving through space, but is frequently described as if it were. 2 entangled particles separated by any distance show correlated measurement results. Measure one and the other's state is determined instantly, regardless of the distance between them. This seems like something travelling faster than light between them. It is not. No information is transmitted. The correlation is real but cannot be used to send a message. The individual measurement results are random, and only by comparing notes through a classical channel, which is limited to C, can the correlation be confirmed. The entanglement is a property of the joint state of the system, not a signal travelling from one particle to the other. The universe allows the correlation. It does not allow the signal. What settles from all of this, if you let it layer without forcing it into a single frame, is a picture of the speed limit that is more nuanced than a ceiling over a race. There is a category of things, massive objects, particles with rest mass, anything with an interior clock, for which C is a limit approached but unreachable. There is a category of things, massless particles and disturbances, for which C is not a limit but the only option. There is a category of things, phases, patterns, correlations, for which the question of speed is technically answerable, but physically empty, because speed without information is speed without meaning. The universe is not running a single race with a single speed limit posted at the finish. It is something more complicated than that. Something with different rules for different kinds of things. And the rule for information, for the physical transfer of causal influence from one place to another, is always, in every case, without exception, not faster than C. Everything else is negotiable. That is not what the limit protects. Stand at the edge of a thought experiment for a moment before going in. You are here and something is there, somewhere distant, and you want to send it a signal, not a fast signal, a signal that travels faster than C. The technology for this is imaginary, but the logic is not. You want to know what happens to the structure of cause and effect if such a thing were possible. Not in practice, in principle. What does the universe look like if information can travel faster than light? The answer is not that things get complicated. The answer is that the word before stops meaning anything. Here is why. In special relativity, there is no absolute simultaneity. Whether two events happen at the same time depends on the observer's frame of reference. But there is something that is preserved across all frames, the causal order of events that are connected by a signal travelling at or below C. If event A causes event B, if A sends a signal to B and B responds to that signal, then A is before B in every reference frame. No amount of motion by any observer changes this. The cause is always before the effect, for all observers, as long as the causal signal travels at or below C. This is not a separate postulate. It falls directly out of the geometry. The light cone, the surface in spacetime traced out by all possible light signals from a given event, divides spacetime into regions. Everything inside the forward light cone of an event can be causally influenced by it. Everything inside the backward light cone causally influenced it. Everything outside the light cone is causally disconnected from the event, neither able to influence it nor be influenced by it, for any signal travelling at or below C. Outside the light cone is called space-like separation, and space-like separated events have no fixed time order. Depending on the observer's frame of motion, event A can be before event B, or simultaneous with it, or after it. There is no fact of the matter for space-like separated events about which came first. Now send the faster-than-light signal. Event A sends a signal faster than C to event B. B receives it and sends a signal back. But because of the relativity of simultaneity, there exists a frame, a valid, physical, non-exotic reference frame, just a frame moving at some velocity relative to the original one, in which B's response is received before A sent the original signal. The effect precedes the cause, not in appearance, not as a measurement artifact, as a geometric fact in a frame that is just as valid as any other. This is not a minor wrinkle, it is the unravelling of sequence itself. It means you could receive an answer before asking the question. It means the concept of cause, as a relationship between events where one produces the other, ceases to have a consistent meaning. It means the universe loses the property of being a place where things happen in an order. Here the rhythm settles. The speed limit is not at its deepest level about speed. It is about the preservation of a structure that makes physics possible, the structure where causes precede effects, the structure where the past is fixed and the future is open, the structure where a signal sent is received after it is sent, not before. These properties feel so basic, so constitutive of what it means for events to happen at all, that they do not appear on the list of things the universe might have chosen differently. But they are not free. They are maintained by the constraint. C is the boundary of the causal past and causal future of every event in space-time. It is the edge of what each moment can reach and be reached by. Without it, or rather, with violations of it, the light cone structure collapses, and with it goes the notion of a consistent physics, a consistent history, a universe in which things follow from other things in a direction that goes only forward. The GPS satellites in orbit around the Earth carry atomic clocks. Those clocks run fast compared to clocks on the ground, about 38 microseconds per day, due to a combination of special relativistic time dilation from their speed and general relativistic time dilation from their altitude. If the clocks were not corrected for this, GPS positions would drift by about 11 kilometers per day. The corrections are built into the system. Every time your phone locates itself, it is using a technology that only works because the speed limit exists. Because the geometry of space-time that the speed limit is part of produces time dilation, and because the engineers who built the system took that geometry seriously. The speed limit does not just protect causality in the abstract. It produces effects that have to be accounted for in concrete systems built by engineers who wanted their systems to work. Ignoring it has practical consequences. The geometry shows up in hardware. There is something about this chapter that I want to name, and it is this. The speed limit tends to be presented as a constraint, as a thing that prevents other things, as a ceiling over motion, a wall against ambition, a cosmic no. And it is those things. But it is also the structure that makes the word because meaningful. It is why one thing following from another is not just a pattern but a fact. It is why the past is the past and not just a convenient convention. The universe did not have to be this way. A universe with a different causal structure, with faster-than-light information, with collapsed light cones, with no preserved time order, would be a coherent mathematical object, but it would not have physics in it. It would not have cause and effect in it. It might not have time in it, in any sense that can be told as a sequence. The limit protects the sequence. The sequence is where everything lives. The stars forming after the gas, the signals arriving after they are sent, the sleep arriving after the long day, the thought arriving after the quiet that preceded it. All of that sequence, all the way down, is held in place by one number that does not move. Something is stopping everything from going any faster, and what it is stopping everything from losing in the process is the order of things, the warmth still leaving. The sun sent light out 8 minutes ago that is only now touching things. Not a striking thing to say, maybe. Not the first time this has been said in this narration. But there is a version of it that goes differently, that goes. The warmth you felt on your face today, the warmth on the back of your hand, the warmth on the side of your face by the window. That warmth left the surface of the sun 8 minutes before you felt it. It was on its way to you before you were standing in that spot. It was already committed to that journey, already crossing the space between the sun and the earth, before you moved to the window, before you turned your face that direction, before the moment when you felt it and registered it as warmth on the skin and went on with whatever you were doing. The warmth you felt was already old when it arrived. This is the thread this chapter follows all the way to its end. Not light speed as a concept, not as physics, as the fact that everything you see is always a version of the past. Every source of light you have ever observed sent its light some time ago. For a lamp in this room, the time is a fraction of a nanosecond, negligible, unmeasurable by anything in the body. For the moon, about 1.3 seconds in the past. For the sun, about 8 minutes. For the nearest star visible to the naked eye from the northern hemisphere, roughly 4 years. For the Andromeda Galaxy, visible as a faint smear in a dark sky, about 2.5 million years. The universe, as seen from here, is a record of light that left its sources at different times and is all arriving now, all hitting the eye at once, a composite image assembled from different depths of the past, a kind of temporal collage that the brain reads as a single present moment. There is no present out there. There is only what has already left. The star you can see tonight, if you are somewhere dark enough to see it, burned that light between 2 and 4 years ago for the nearest ones, hundreds or thousands of years ago for most of the visible ones. Some of the points of light in a clear sky are from stars that no longer exist. The light outlasted the source. The source went quiet at some point, collapsed, exploded, cooled, went, and the last light it sent is still travelling, still arriving at various planets and moons and dark patches of space, being absorbed or reflected, carrying a record of a thing that no longer is. You cannot tell, by looking, which ones are still there. The light does not carry that information. It carries only what the source was doing when the light left. The present state of the source is inaccessible, separated from you by a distance no signal has yet crossed. The speed of light is the rate at which news travels in this universe. Everything you know about the state of distant things is news that has been travelling for some time. The further away the thing, the older the news. At cosmological distances, the most distant observable galaxies, the cosmic microwave background, the news is billions of years old, showing a universe that looked entirely different from the one that exists now, if exists is even the right word for something happening so far away that the concept of now becomes unclear. The universe is not a place where all things are equally present to each other. It is a place structured by light travel time, where every point has access to an expanding sphere of past information and no access at all to the present state of anything beyond its immediate surroundings. Causality is local in the end, not because the universe is small, but because C is finite, and the news takes time, and there is no way around that. There is no way around that. You are horizontal, probably. The room has its particular temperature, its particular quality of dark. Whatever light is in the room arrived at your eye a nanosecond ago or less, already old, already past. Your own body is sending light right now. Infrared radiation, heat, the electromagnetic signature of a warm living thing. And that light is leaving you at sea in all directions, and will continue to do so for some time, carrying a record of your warmth outward through the room and through the walls and into the night, diminishing with distance but not stopping, heading somewhere, carrying whatever information a warm body at rest in a room at this hour constitutes. Some of it is already gone further than you will ever go. The warmth is still leaving. It left while you were reading this sentence, and it left while you were reading the one before it, and it will leave while you read the next thing, whatever the next thing is. The body emits. The emission travels. The universe receives it. At the edges of wherever it reaches, long after the source, you, here, tonight, in this particular arrangement of cells and warmth and attention, has changed into something else, or stopped entirely. The speed limit means the warmth travels at a rate, finite, specific. The warmth takes time to go. That is the whole thing. That is what all of it comes down to if you let it come down to something small enough to hold. The warmth takes time, and it goes, and it is still going, and will be, for longer than feels possible to think about from this room at this hour, at this particular place in the night, which is already a moment that is becoming past, already becoming the kind of thing that would take light some small fraction of a second to report back to you if reporting were possible. Already behind the only edge that has never moved and will never move and does not care whether anything that passes it arrives or does not. It just goes, at that speed, into whatever is next.